Hi everyone, let me introduce myself. I am Pibun Sikam from School of Renewable Energy, Metro University. Today, I am going to talk about performance enhancement of hot air, fruit dryer with infrared heating system. I am begin with introduction. Drying or dehydration is an etc. technique in food processing and preservation process. It is used to remove water from product in order to discream microbiological activity and limit physical chemicals such as drying storage. The humidity should be below 12% with standard. Most use hot air temperature 40 and 70 degrees Celsius. As use the air circulation as 1 to 2 meter per second. Sensing the insight is that it take a long time today. Therefore, infrared radiation is set, which can reduce the drying time by up to 50%. An original hot air dryer in the reserve hot technique and approximately 5 millimeter drying chamber. There were 10 secret drying tasks with a diameter of 90 centimeters. All drying tasks can be rotated as the summer rotation speed is the rate of 1 to 10 respiration per minute. For dyeing performance assessment methodology and infrared lamp was introduced as a displacement of 20 cm. Begin with experimental setup. The objective of the experiment was to evaluate the performance of original hot air dryer to compare it with modified version by SD the infrared heating system. This leads directly to my next point. The experiment used 10 kilograms of copper lighting. The standard installed humidity is 60% weight. Dye with hot air is 45, 55 and 65 degrees Celsius. Compared to the use of hot air combined with 300 watts of infrared at the same temperature and with speed. Begin with result and declusion. From hybrid drying, the drying time was reduced to 200, 120, and 110 min. When operates with hot air temperature 45, 55, and 65, lending to time service to about 70, 67, and 49% respectively. The hybrid system has a higher asphalt drying rate. That's the Torino quantitative dryings by 230, 200, and 145%, which refers to compressing hot air. It was found that the modified dryer operated its hybrid modes produce chemical gas dehydrated carefully. Infrared heating was found to improve the energy efficiency of the dryer from 40.21 to 36.11%, from 30.03 for 40.55%, and from to 50.51% for 45, 55, and 65 respectively. From detailed result it was found that about 10 courses produce purified goods with multiple different in dyeing time, energy efficiency, and product quality. Higher process temperature produce the final decided coverality with most bold color and keep filtered that has lower market price. This moment of infrared heating with traditional hot air converters drying significantly is proof the drying performance reduces the process time and energy consumption. In the case of 65 hot air combined with infrared 300 watt, the maximum energy efficiency of the dryer was raised from about 60 to 54%, which reduced drying time and reduced over power consumption by 17%. The optimum hot air temperature for the hybrid drying the clothes. Maintains high dryer performance and produce high product quality should not be above 55 Celsius as this condition the modified dryer needed only about 100 min to product. The highest differentially with acceptable moisture content and water activity variation. Begin with environment. This was partly supported by the Thailand as Agricultural Research Development Agency, National Research Council of Thailand, Major University, and Chiang Mai University. Thank you all for listening. It was a pleasure being host today.